I hope you remember. Let us open the same file what we were using in last lecture, that is banklon.xls. Hope you remember we estimated a multiple regression with the ordinary least square method. The dependent was income and independent were employment, debt to income ratio, and credit to debt ratio. These three were independent variables. Okay, these were the results. I had interpreted these results for you people. Now let me show you. There are more statistics which we can obtain in Gretl, and these statistics are like we can go to analyze of option given in the results. Okay, we can get the confidence interval for these coefficients. Okay, for each coefficient the confidence interval is being constructed. I hope you people remember that includes if this confidence interval includes zero, then we say the coefficient is statistically insignificant. If it doesn't include any zero, then coefficient is statistically significant. Since means your constant can assume any value between 25.1648 to 33.2204. Means if we go with the 95% confidence interval or 5% error, then all these values are possible for the constant. Similarly, the coefficient of employment can be considered within the range 2.00138 to 2.57072. See, many times reviewers, whenever you submit the paper to journals, reviewers are interested in knowing these confidence intervals. Okay, they are not interested only in your coefficient value. So these confidence intervals are very much helpful, because if your confidence interval suppose is from minus 2 point something to say 1 point something positive, it means this confidence interval includes zero. So when this includes zero, your coefficient will be statistically insignificant, because zero can be taken as one of the value of your coefficient. When zero can be taken as one of your value of coefficient, it means your coefficient doesn't significantly differ from zero. So in this example, all the coefficients differ significantly from zero, because no confidence interval is containing zero. Means you can say the employment coefficient, they are positive only. Both sides lower interval and the lower limit and upper limit of the interval. And here debt to income ratio, again both are negative. No zero is contained. For credit to debt ratio, no zero is contained. So this is the confidence bound that you can obtain for 95% level of significance. I hope you people remember the formula how to construct a confidence bound. Suppose I want to construct confidence interval for beta 1 cap. Okay, hope you remember the model that we were doing in last lecture. That was yi is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus ui. So if I have to construct the confidence interval for beta 1 cap, I can write it as beta 1 cap plus minus t 0.05 for v is equal to n minus k degree of freedom, standard error of beta 1 cap. Okay, t if the sample size is large can be read as z. Okay, so beta 1 cap plus z 0.05 v is equal to there is no need of v if sample size is large, because then z 0.05 tabulated value of z will be 1.96 for 95% confidence interval and 5% level of significance. So can I write it as there will be one value beta 1 cap minus z 0.05 into standard error of beta 1 cap. I can write it as the under root variance of beta 1 cap. Okay, because standard error is nothing but under root variance. And second, at the upper interval, I can write it as upper value of the interval. I can write as this variance of beta 1 cap. Right. So this is the interval that has been constructed by Gretel in using what we say the yeah using this analysis option. Okay. Now further in analysis we have many other options, like we can build an ANOVA table, go to analysis of your results, analysis menu of your results, click on ANOVA. See, we can get the ANOVA results. Okay, this is the ANOVA table, F statistics. Okay, this F statistics is available with the p-value 0.000. Basically, we can observe that F is statistically significant, so overall fit is good. All the slope parameters significantly differ from zero, or at least one slope parameter significantly differ from zero, so fit is good. And a significant variation in level of income is explained by the three variables we have included into our model. Uh, then we have many other analysis. For example, the problem of multicollinearity we have to observe. Then hope you remember what is multicollinearity, since we are estimating a regression. Yi is equal to beta naught plus beta 1 x1i plus beta 2 x2i plus beta 3 x3i. The three independent variables are there. Let me tell you people that none of the pair of three independent variables should be significantly correlated. We generally say that expected value of x1 and x2 must be 0, x2 and x3 must be 0, and x1 and x3 must be 0. So there must be no correlation among any two independent variables. Okay, that will be called absence of multicollinearity. This is assumption of method of ordinary least square. Okay, assumption is no multicollinearity, but if this multicollinearity exists, then we face many problems. In case of perfect multicollinearity, the coefficients are 0 by 0, they become indeterminate. We have means our variance rises if multicollinearity is present, and as variance rises, test of significance becomes invalid, because if variance will increase, standard error will increase, and ultimately your z and t will become statistically insignificant, even if they are statistically significant. Okay, it means there is the whenever problem of multicollinearity, generally what happens, many students they come to me, they ask, sir, the coefficients are very large, what to do? I generally advise them to check for the existence of multicollinearity, because due to multicollinearity, generally your coefficients will be very high, and your t values, z statistics of all those coefficients will be statistically insignificant. Okay, and this is the result of existence of multicollinearity. So multicollinearity must be avoided. How to check the existence of multicollinearity? Let us see. Go to analyze. There is option collinearity. Click here. We can see there are many statistics of multicollinearity available within Gretel. Okay. See, these are the different collinearity statistics available with Gretel. We can say that first of all we have variance inflation factor. यहाँ पे देखिए लिखा भी हुआ है value greater than 10 may indicate a collinearity problem. So for each independent variable, this value is below 10. We can say that multicollinearity is not very much serious in our analysis, whatever we have performed. So there doesn't exist the problem of multicollinearity. Further, there are different other statistics. uh, वो आप लोगों ने पढ़े नहीं हुए बच्चे, फिर भी बी के डब्ल्यू कोलिनियरिटी डायग्नोस्टिक इज देयर. वी हैव eigen value of inverse covariance matrix. uh, we have conditioned index, we have a variance proportion column sum to unity. Okay, so there are many statistics available. Hello. So, but multicollinearity is not so much serious in our case. See, with the BKW, according to BKW test, a collinearity diagnostic, what we say condition index must be greater than condition index must be less than what you say 10. यहाँ पे ranges are given. We say condition index greater than equal to 30 indicates strong near linear dependence, strong multicollinearity. Between 10 to 30, moderate or strong multicollinearity. Variance is mostly associated with problematic condition values, may themselves be considered problematic. Count of condition indices greater than equal to 30. There is no variable for which this is greater than 30. Count of condition indices greater than equal to 10. No variable is present. So no evidence of excessive multicollinearity is there. Uh, but let me tell you, most of the time, see, for talking about these lambdas, I will have to teach you people the linear dependence and independence of matrices and calculation of eigenvalues. Hope you remember uh, A minus lambda determinant is equal to 0. Remember this linear and independence and dependence of vectors? Now, when we use this, we calculate the roots of lambda, and these roots of lambda are called eigenvalues. Now, here in matrix A is nothing. Here, matrix I is the identity matrix, lambda is the lambda parameter, and this A is nothing but inverse covariance matrices. Matrix. We compute the covariances and compute the inverse of that covariance matrix. Whatever inverse we get, that inverse is called A. So A minus lambda I determinant, put that determinant is equal to 0, you will be getting the value of lambda for each each variable you will be getting some lambda. So there are four variables, four roots will be present, four parameters, four roots will be present, and so on. We have constant, we have employment, we have debt income ratio, we have credit to debt ratio. All the values are given, right? So when there are four parameters, 4 by 4 matrix will be available. So for 4 by 4 matrix, four roots have been computed. Once four roots have been computed, no root for employment, no root for debt to income ratio, no root for credit to debt ratio is exceeding the prescribed limits. We can say condition index has been constructed using these lambdas. It is not exceeding. Variance inflation factor, I hope you remember VIF is nothing but uh, variance inflation factor is, say, for variable x1, it would be 1 upon 1 minus r square x1 dot x2 x3. Okay, rx1 dot x2 x3 is nothing but the coefficient of multiple correlation, and the square of that is called coefficient of multiple determinant, that represent variation in x1 explained by x2 and x3. Okay, uh, where we can say that rx1 dot x2 x3 is nothing but r1 dot 23, okay, is equal to, I had given you the formula, that was R12 square plus R13 square minus 2 R12 R13 R23 upon 1 minus R23 square. This is the formula of R1.23, and square of this, obviously you remove this under root, the square root, you will be getting the Rx1 dot x2 x3 square, right? Similarly, variance inflation factor for x2 can be computed. VIF for x2 can be computed as 1 upon 1 minus r x2 dot x1 x3 square. Okay, formula you can write for, you can see this formula in any book of statistics. What would be the formula of r2.13? VIF of x3 would be 1 upon 1 minus r x3 dot x1 x2 square. Okay, so this is variance inflation factor for X3. VIF must be less than 10 if we say there is no serious multicollinearity. If we have to conclude that there is no serious multicollinearity, you may observe, you may notice from these results that for any independent variable, the three independent variables we have included, no variable VIF for no variable is exceeding 10. That's why multicollinearity is absent. So, there is, that was the check of multicollinearity. Now I show you another. We have coefficient covariance matrices also. This is the coefficient covariance matrix. Okay. Uh, this coefficient covariance matrix, you can see constant. This is the variance of beta node. Okay. This is covariance of beta naught beta 1. This is covariance of beta naught and beta 2. This is covariance of beta naught and beta 3, right? Similarly, if we compute employment, or this is variance, all diagonals are basically variances of parameter. This is variance of beta 1. Okay, covariance of beta 1 and beta 2, covariance of beta 1 and beta 3, variance of beta 2, covariance of beta 2 beta 3, and this is variance of beta 3. Okay, so this is variance covariance matrix. In case you need this matrix, you can have this matrix from the analyze option of this Gretel, means the output of Gretel. Uh, Many times we use these variance and covariances as the weights. So that this matrix can be observed. Okay, we can obtain actual and fitted actual value, fitted value, and residual value. So display actual, fitted, and residual. You can see this is the actual value of income, 176. Fitted value is 166.32, and residual is of 9.68, and so on. So for each observations, this is yi, this is yi cap, fitted is yi cap, so yi minus yi cap is residual. So EI series is also given. You can copy paste this series anywhere else, wherever you want. Uh, then we have, see, if you want to see the QQ plot of residual. See, QQ plot is used to see whether some variable is normal or not. Residual QQ plot can be constructed. See, this is the line of normality, the red line. Okay, more convergence to this line represent more normality. Less convergence means less normality. You can see there are many outliers here at the tail. Though up to this point, this is, residual is converging to normal, variate normal line, that red line. But after this, there are many outliers. Anyhow, see, we won't be using this method right now. The residual plot. you can have residue plot against any independent variable. For example, many times to check heteroskedasticity, hope you remember what we do. Uh, Heteroskedasticity, we say variance must be constant. I hope you remember the one of the assumption of OLS is homoskedasticity, that error must be having constant variance. Okay, we say expected value of EI square must be sigma u square, that is a constant, or expected value of ui square must be is equal to sigma u square, a constant. Okay, this is called homoskedasticity. Okay, is OLS assumption of homoskedasticity. Okay, however, if expected value of ui square not is equal to sigma u square, or expected value of ui square is equal to sigma I square, means it changes with change in value of I. This is called, then we say, there exists problem of heteroskedasticity. Now again, there are different consequences of heteroskedasticity. Though your parameter estimates remain unbiased, but the estimates become less uh, consistent because variance rises. As variance rises, their consistency falls, the efficiency of variance falls. Uh, so efficiency of the parameters fall, and when variance rises, test of significance becomes invalid. That's why the problem of heteroskedasticity is serious in OLS estimation. How to check for the heteroskedasticity? One very common method is, what you do, you plot residual against any independent variable. If a significant correlation, positive or negative, if some trend or downward or upward trend is shown in this plot, in this scatter plot, then you can say that heteroskedasticity is present. What we can do, we can plot this residual graph against employment, the first independent variable. We can see there is no significant trend here. Okay, uh, see, it's no significant trend is observed. Again, we can plot uh, residual plot against employment. This is against employment, no trend is seen. Okay, uh, graph residual plot against debt to income ratio. Okay, again this scatter doesn't represent any trend. Graph residual plot credit to debt, again this is not representing any trend, neither downward nor upward trend is shown. So we can say that there is no problem of heteroskedasticity, as no trend is seen between no trend is seen in any plot, any two-dimensional plot between variables residual and one of the independent variables. So heteroskedasticity is missing. We can have many other, uh, the many other statistics, like we have heteroskedasticity test. Go to test menu. Okay, white test is there, white test squared only, Brucian Pagan, then Coinker test is there. Let us go for white test of heteroskedasticity. This is the white test of heteroskedasticity. What is the regression? Constant employment debt credit to debt ratio, square of employment x2 x3. Okay, the square of employment is obviously uh, x1 square, x1, x2, x3, x2. These are the cross products of variables and square of debt. What is this basically? This is EI square is regress. EI square is nothing. Means what in white test what is happening? White test of heteroskedasticity. What is happening? EI square is regressed upon, EI square is regressed upon, you can see the level variables, the squares of level variables and cross products. Since we are taking three independent variables x1, x2, x3, so step one mein what you will be doing, you will be estimating the multiple regression model. Step two, obtain the residuals and square of residuals. Step 3, regress square of residual like this upon, say, let it be alpha naught plus alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3 plus alpha 4 x1 square plus alpha 5 x2 square plus alpha 6 x3 square plus alpha 7 x1 x2 plus alpha 8 x2 x3 plus alpha 9 x1 x3 plus vi. Vi is the residual of this regression. So we are estimating this auxiliary equation. Okay, when this auxiliary equation is estimated, bache, then what will be happening? We obtain nr square. Uh, we obtain n into r square for this auxiliary equation. Okay, means after estimating this equation, some r square is obtained and we multiply n with this r square. This nr square is called lambda max statistics. Okay, this lambda max lm approaches to chi-square variate. Okay, this approach is to chi-square variate. Now, when this approach is to chi-square variate, we can use chi-square test. We can observe here t is n basically. So t r square is given. T is number of items in this for number of cross-sectional units if it's a cross-sectional data, and if it is a time series data, t will be number of time periods. So T r square is n r square, which is basically LM statistics. 340.88337 is the statistics, and p value is 0.000 less than level of significance. So let me tell you, bache, the null hypothesis here is homoskedasticity against the alternative heteroskedasticity. Okay. Now, observation, from this observation, if we go by this LM statistics and p-value, we can say the null of homoskedasticity is rejected. So there exists the problem of heteroskedasticity, though it was not very much clear with the scatter plot. With white test, which is more powerful test, it is evident that there exists the problem of heteroskedasticity in this estimation, where we have one dependent, that is income, and three independent variables, a number of years in current employment, debt to income ratio, and credit to debt ratio. So in this estimated model, heteroskedasticity is present. White test is confirming the existence of heteroskedasticity. So, Bache, today I have told you the uh, different statistics available after multiple regression estimation, the test of multicollinearity, and test of heteroskedasticity. Autocorrelation we won't be touching right now because it is more related to what we say the time series analysis. So whenever we will be performing time series analysis, then I will be telling you what is the autocorrelation problem. Okay. So again, I have told you the test of normality, where we tested whether residual is normal or not using Q2 statistics. If you want to have test of normality for any variable, uh, we had variable, go to variable, select variable here in variable window, go to variable menu, we have normality test. These are various normality tests available. Even you can do one thing, you can store the residual and apply the statistics test of normality. We have many normality tests. Null is normality against the alternative of normal variable. You can see all these variables with all those tests statistics are having a p-value less than 0.05. So ultimately they are rejecting the null of normality, so variable is non-normal in nature. Even Zarkowara statistics is uh, telling us the variable is non-normal in nature. Anyhow, center limit many times says when data is large, then most of the distribution, the approach is to normality. Anyhow, I have told you the test of normality also. QQ plot can also be made to see whether the variable is normal or not. See, this normal QQ plot can be constructed. For any variable, you can construct this QQ plot. This green line must converge to this line of normality. More deviation from this line, it means non-normality does exist. Okay. Uh, So, but we will continue with more statistics in coming session. Okay. Thank you so much for the day. Now I will be taking your attendance.